In this lesson, I will provide an overview of radars from a non-equation perspective. Radar is an acronym for Radio Detection and Ranging, which was developed during the pre-World War II era. Driven by general war events, the radar technology received a strong development boost during the World War II. Radars can determine the range, detection, altitude, direction, or speed of objects and have two modes of operation, pulsed and continuous. Pulse radars transmit a high-frequency signal. After this impulse signal, a long break follows, which the echoes can be received before a new transmitted signal is sent. Continuous radars transmit a high-frequency signal continuously. The echo signal is received and processed. The receiver, however, does not need to be mounted in the same place as the transmitter. Radar is an active sensor, and you know from the lesson on remote sensing that active sensors provide their own illumination, which can operate in either day or night. Also, a radar can be configured using either a monostatic, bistatic, multistatic, or passive modes. In a monostatic radar, the transmitted and receiver are co-located. In a bistatic radar, a transmitter and receiver are separated by a distance which is comparable to the expected target distance. For a multistatic radar, multiple spatially diverse monostatic or bistatic radar components share an area's coverage. A passive radar detects and tracks objects by processing reflections from non-cooperative sources of illumination in an environment. Radar systems work in a wide band of transmitted frequencies. The higher the frequency of a radar, the more it is affected by weather conditions such as rain or clouds. But the higher the transmitted frequency, the better is the accuracy of the radar system. Example of bands include the VHF and UHF, which are for very long-range surveillance. The C-band operating in the range of 4 to 8 gigahertz for long-range tracking and airborne weather systems. And the Ku band is for high-resolution mapping and satellite altimetry. Examples of active remote sensing include radar, which I explained in the previous slide, Lidar and Sonar. Lidar measures the distance by illuminating a target with a laser and examining the reflected light. Sonar, of course, is a technique to use sound propagation to navigate, communicate with, or detect objects on or under the surface of water. There are two types of radars. An imaging radar forms a picture of the observed object or area. Imaging radars have been used to map the Earth, other planets, asteroids, or celestial objects, and to categorize targets for military systems. Typically, implementations of a non-radar system are speed gauges or radar altimeters. These are also called scatterometers since they measure the scattering properties of the object or region being observed. Non-imaging secondary radar applications are immobilizer systems in some recent private cars. Non-imaging secondary radar applications are immobilizer systems in some recent private cars. The basic idea behind radar is very simple. A signal is transmitted, it bounces off an object, and is later received by a receiver.